All right, this is a challenging question, but I know that it's a question that you can do. So this says if a solution of HF has a pH of 3.4, what is the concentration of hydrofluoric acid? Okay, now keep in mind, hydrofluoric acid is HF. It's going to react with H2O to make H3O plus, which I always denote as H plus F minus. Okay, now what this is telling us is it's giving us pH information, which if we have pH information, we can figure out what our hydrogen ion concentration is. And this is, of course, at equilibrium. So we know that negative log X equals our pH. Sorry, not of X, but of our hydrogen ion concentration. That's going to be our pH. So if we're given our pH, then what we want to do is take, the negative pH 3.40 and raise that 10 to the, or raise a number 10 to the negative 3.4 power. That's going to be, well, 3.98 times 10 to the negative fourth. So that gives us our hydrogen ion concentration at equilibrium. Okay. Now the question is, how do we use that information to figure out our hydrofluoric acid concentration? Well, the way that we're going to do that is we're going to kind of work backwards a little bit, because we know that whenever we add our hydrofluoric acid to, or we know that we have a weak acid with an equilibrium expression of K sub A. K sub A is going to be equal to our hydrogen ion concentration times our fluoride concentration divided by HF. Okay, so that's ultimately equal to 6.8 times 10 to the negative fourth. What we can do is we can look at our reaction here, and we can look at it as a 1-to-1-to-1 reaction. And so we can say 6.8 times 10 to the negative fourth is equal to, well, our hydrogen ion concentration, which we actually know is 3.98 times 10 to the negative fourth times that same 3.98, because that's also going to be our F minus concentration times 10 to the negative fourth over our HF. Okay, so what we're going to do is then the algebra to basically move the concentration of HF to a place by itself. So we're going to have HF concentration is equal to 3.98 times 10 to the negative fourth squared divided by 6.8 times 10 to the negative fourth. So I'm going to plug that in. 3.98 times 10 to the negative fourth, close parentheses, and square that. Divide that by parentheses 6.8 times 10 to the negative fourth, close parentheses. And what I get is HF is equal to 2.33 times 10 to the negative fourth. And that is my, that's going to be my concentration of my hydrofluoric acid at equilibrium. All right, I hope that was helpful and have a good one.